My title
Yes,
slide.
looks great.
Oh, sounds great. Well, good morning, everyone, or comment ça va, as we'd say down in Cajun country, as you might detect. I'm a Cajun from South Louisiana, and I'm speaking to you today from my home in Baton Rouge, Louisiana. My name is Claudette Hanks Reichel. I am a professor and extension housing specialist, so I work with real people instead of college students. I'm over at Louisiana State University with the AgCenter, and I'm also director of the La House Resource Center, in case you've ever heard of it. It's an educational outreach program and kind of a life-size showcase or exhibit on campus of a variety of resilient, high-performance housing solutions for the southern region climate and our natural hazards. I'm also very happy to introduce my co-presenter, Theresa Gilbride. She's with the U.S. Department of Energy's Pacific Northwest National Laboratory. She's a scientist who works with DOE's Building America and Zero Energy Ready Home programs. Today, Terry and I are going to illustrate and talk about how energy efficiency and resilience can and do go hand in hand in high performance homes. So getting rolling here. You know, if it seems like, you know, it just really seems like there's a lot more disasters than you remember in your youth, it's not selective memory. The last decade has indeed doubled the number of billion-dollar disasters from the previous 2 decades and quadrupled from the one before. And those costs are adjusted for inflation. So the rise is real and it's alarming. So think about it. Who pays those costs? It's not just the disaster victims, it's all of us in disaster assistance. Terry?
Yeah, thank you. So indeed, natural disasters are on the rise. I'm from the Pacific Northwest, the land of wildfires and high winds and possibly earthquakes. So we've all got, no matter where you are in the country, there's something to be concerned about. If there's any silver lining to this cloud of severe weather events we've been experiencing, they are an opportunity to rebuild better. And I think you guys have definitely seen that in Texas with Harvey. Rather than just reacting and throwing up new construction as quickly as possible, we can take a more thoughtful approach to rebuild with future storm resistance and resilience in mind. In this presentation, we're going to talk about how these 3 R's, how they are compatible with building high performance, high efficiency homes. We'll emphasize some high efficiency construction practices and examples from Building America and DOE's Zero Energy Ready Home programs, as well as some lessons learned from recent disasters. Next. So I think the overall theme here is that if you are building an energy efficient home, you are building for disaster resistance. There's so much compatibility between the 2 programs, between the 2 efforts, especially if you're building to one of these national programs like DOE Zero Energy Ready Home, Energy Star, and Air Plus. There's so much in those programs that will also make a home more resistant or resilient after a disaster. Next. Another program that's out there is the Insurance Institute for Business and Home Safety's Fortified Home program. They have their fortified house, their silver level, and their gold level home labeling program. They're voluntary programs. It's sponsored by the insurance industry. Their main focus is on high wind and hurricane resistance, with a big emphasis on roofs, because frankly, that's what a lot of the insurance money goes to, is to pay for roof replacements. But so much damage happens to the house because of water intrusion, wind pressures through the roof. So the guidance that they're recommending can also make homes more tornado, earthquake, and fire resistant. Another another great source of disaster resistance information is FEMA. And a lot of the best practices that they recommend are complementary to, in fact, the same recommendations that you'll get from DOE's Building America program, like weather stripping doors and windows, using water resistant flooring, sloping the grade around the house, sloping paved surfaces away from the house, pan flashing at windows and doors. All these measures make a house more durable, can make it more wind resistant, cut drafts, etc., but they also make it more resistant to high winds and stormwater intrusion. Next.
Okay, look at this map. Flooding is the most common disaster nationwide. And I think, we may realize that, but here on this map, only those areas in brown are the only counties in the country that have never had a declared flood disaster. It's almost everywhere except in the mountains. And another recent statistic that I learned is that in 90% of all disasters of all types, 90% of them also include some flooding. So that's why flood resistance, resilience, and recovery are so crucial or so important. It happens almost everywhere in our country, and the impact tends to affect thousands, not just hundreds, but thousands and thousands of homes at one time. And that creates massive obstacles to recovery. It's not only a grueling, hazardous, and expensive ordeal and tragedy for people that is not covered by homeowners insurance, but owners have to compete with the thousands and thousands of other people for materials and for qualified contractors who are all in short supply. And so the scammers and the shoddy fly-by-nighters swoop in from other states to take advantage of folks who are just desperate to restore their homes and lives. And then they end up with shoddy or unfinished work and the loss of their life savings. I've seen it happen so many times. So that is why we really, in new construction, it is so crucial to have flood resilience in most places in this country. And that means if it is an actual flood zone on the flood map, don't just build to the BFE, the base flood elevation, the minimum required, but elevating 2 to 3 feet above that not only gives a cushion of safety, but lower flood insurance premiums. So there's a financial benefit and incentive to do that. There are various ways to do it, so you can get different kinds of looks in the home. But what I'd also like to submit to you is to encourage people to take it further. In addition to elevating above the BFE, or if you're not even in a flood zone, look at concept of wet floodproofing. It doesn't have to be all or nothing. Any of it that you do can save ordeal and money and speed up the time you can get back into your home. You know that, in Texas especially, 75% of the people who flooded in those Houston floods in 16 and 17, were not in a flood zone. It happens all the time. And so if you can wet flood proof, which means elevating what you can, equipment, some utilities, maybe wiring, using water damage resistant materials, and considering concepts to make it easy to open up and dry, like removing the wainscoting or having a drainable wall. But the term I really prefer to use is flood hardy, because people understand that. Wet flood proofing, nobody knows what that means. So I don't really use that term. Flood hardy, what is that? That concept is kind of, what I've been sort of preaching and promoting, encouraging people to consider. It's about using flood damage resistant materials in a washable, drainable, dryable assembly, so that if it ever floods, there is not a need to gut, open everything up, throw everything away, and wait in line with 100,000 other people for scarce and expensive materials, end up with Chinese drywall and fly-by-night contractors, like so many people have become victim to. Let's not have people become victims twice. And so this is one way to do that. Yes, it is better to elevate above the possible flood level. And building above that BFE is required, but as you know, and I've already mentioned, that is often not nearly high enough. So people may not want to be high above the possible flood level because they don't want to deal with that many steps and it is more expensive, but using flood hardy assembly methods can be a compromise measure. Now there is an ASTM E3075 test method that manufacturers can use to verify that their material meets a new standard of flood resistance. And so do look for that. But still, FEMA for a long time has had this technical bulletin too that classifies the flood damage resistance of generic types of building materials. And it all kinds of materials, but I'm just showing one here. Typically, the insulation in walls and underfloors is often the most vulnerable material. Also, you know, fiberboard, sheathing, OSB, and that's what requires the gutting because they must be replaced if they get wet. But here you see there's a type of insulation. The closed cell foams, whether spray or rigid, meet the highest level of flood damage resistance. So that opens up some possibilities. That in mind, after Hurricane Katrina, Building Science Corporation partnered with my program and a local nonprofit in New Orleans on a Department of Energy's Building America project to explore a better way to rebuild, with 2 prototype houses for low-income families whose homes were destroyed by the flooding of Katrina. But I call these the wash and wear houses, and I'll show you why. These 2 homes were designed and built to integrate high energy efficiency, because it's a DOE program, but with a flood hardy wood frame building assembly, because that is the common type of construction. That was also built to be 130 mile/hour wind resistant, termite resistant, because the hotbed of the Formosan termite, and highly moisture managed and healthy to live in as well. They were called the Green Dream Homes, named that by the local nonprofit, because isn't that what sustainable and green really should mean? That it's hardy and can survive natural hazards as well as save energy. Here you see a couple of section drawings that show the concept of the drainable, dryable building assembly, wood frame building assembly, and with 2 different types of foundations, the pier and beam and the stem wall foundation. So after a flood, you just remove the interior trim, the baseboard, the crown molding, or the chair rail, and you use gaps that have purposely been left between panels of drywall, leaving some gaps behind them to have a gap, a space to flush out, to wash with a detergent solution, rinse with a sanitizing rinse, drain it so it can drain, and then dehumidify to speed dry everything. Then you just put back the trim, wash and wear. So specifics on these 2 prototype homes, they were elevated to 5 feet above grade, which is 2 feet above the BFE, but the flood depth here after the levees failed was really 8 to 10 feet. So you see, it's possible to flood beyond that if, or shall I say, when the levees fail again, that could happen. So the floors and the walls were built with flood hardy materials. They used all solid wood and treated plywood, both which will take in water, but they tend to recover and withstand flooding and recover without delaminating and without damage, or just some swelling, but they come back. So they tend to hold up pretty well, even if it's not marine grade. The interior was paperless drywall, which has a fiberglass mat instead of paper facing and a moisture resistant core. So it is a very flood damage resistant material on the FEMA analysis. And it also provides no food for mold, afterwards. There was ceramic tile flooring, and then the siding was fiber cement siding and trim, which can withstand the flooding very easily as well. Under those raised floors, one of the subfloors used closed cell spray foam on the subfloor between the joists and also on the rim. And since it's a fully open pier and beam space, a joist in our climate did not need to be coated, in this warm climate, but in a cooler climate, we would recommend that. The other subfloor was insulated with a foil-faced rigid foam board that was fire rated and taped and sealed airtight. Kind of laborious, but works beautifully. And after a flood, you could just cut sections, let it drain, and put it back. So it's very robust after a flood situation. Those two floor insulation systems also happen to be solutions to a very common problem in my climate, and that is our raised floors rot and cup in the summer. The water vapor drive is inward in a warm climate, and the cooler you air condition, the stronger the drive. Plus, the cooler you air condition, the more likely that you're going to make these materials be dropped below the outdoor dew point, which in the summer around here can be 76 for, a lot of the time. And so, if you're cooling cooler than 76, you're going to have wet subfloors. So you combine cold air conditioning, the colder the thermostat, the worse the problem, plus impermeable floorings like vinyl or laminate or polyurethane coatings on wood. And then you worsen it with fibrous insulation that allows moisture to go right through it and reach that cold subfloor, but it keeps the subfloor from ever warming up because it insulates it. Those three things add up. That is like a formula or a recipe to add up to wet subfloors, cupped flooring, mold, decay, and then all that moisture attracts termites. So again, those same two subfloor insulation systems we just saw are what we recommend as a solution to this problem as well. Now, the key to a flood-hardy house is that closed cell insulation and assemblies that can be flushed, drained, and dried. So one of the houses used a partial fill of closed cell spray foam just to 60% of the cavity, leaving space for drainage, for flushing, draining, and drying. The other house used only exterior rigid isocyanurate foam board. You could use extruded polystyrene, even better, leaving the wall cavities completely empty, and that provides even faster drying capacity. So, an even more robust flood-hardy assembly. Of course, the houses need good drainage, a drainable weather-resistant barrier, and a gap, which is always recommended, not only in our rainy climate, but anytime you would have OSB, you need that drainage gap because it doesn't handle the moisture the same way as traditional plywood. But anyway, so these homes, the one that had the spray foam in the walls, it had a house wrap, a non-perforated house wrap with a screen wrap excluder at the bottom, but furring strips over it, and then the fiber cement siding was put over that. So that creates the drainage and the weather-resistant barrier. The other house that had the exterior insulation had the house wrap right over the plywood. The bottom flashing and insect screen draped over that bottom flashing as an insect excluder. Then the 2 inches of rigid foil-faced foam to provide, the R value that's needed over the house wrap. The house wrap's a weather-resistant barrier. Furring strips over the rigid foam, provide the drainage gap, but also a nail base for attaching the fiber cement siding. Now, of course, because of the thickness, the windows need to be trimmed out. That was a little bit of a learning curve, but there are you know, ways to do that that have been determined and figured out, because in other parts of the country, it's a common practice. Joe Stiebrick of Building Science Corporation has also fairly recently published a new idea, a new flood hardy assembly that I think is just brilliant. It uses extruded polystyrene foam board, the XPS foam board, in place of the wood sheathing, combined with closed cell spray foam inside the cavities, because the closed cell spray foam provides the racking resistance that wood sheathing normally would be used for. So it provides the racking resistance instead of the wood sheathing. And then that foam board adds additional R value, additional energy efficiency, and even more robust water damage resistance than plywood. Nothing to soak up water or to mold or to delaminate. So this is, you know, very interesting solution as well. Okay, that's all new construction. Now, what about restoring existing flooded homes to be more resilient and energy efficient? You know, flooded homes are typically not destroyed, but, you know, restoration questions, confusion, complications, and conflicting information is rampant, along with little or no money for restoration. Even people with flood insurance may have, you know, or not really given enough money to improve it, only to put it back the way it was, which is a shame. But that may be about to change. That's another story. Anyway, in 2016, 17, and 18, about 300,000 homes were flooded in Louisiana and Texas. Most of these homes are slab on grade with brick veneer. Uh-oh. How do you handle that? After fielding a flood of questions from the 2016 and 17 floods, yeah, pun intended, my team and I developed, and we posted online, the FAQs after gutting your flooded home, because homeowners and their contractors, they needed answers that addressed their reality with doable options and pros and cons and considerations, so that they could make their own informed choices within their capacity, within their means. I'm not going to go through all the FAQs. There's 20 something of them, but we don't have time for that. But the big dilemma that many people grappled with was how to replace that damaged sheathing. They had this old blackboard fiberboard that was like moldy and mush and just toasted, you know, and so it was removed. But they had brick veneer. Well, of course, the best practice, the official best practice, is to remove all that brick veneer, replace the sheathing, replace the weather-resistant barrier. But the reality was and is not going to happen. It didn't happen. People don't have the money to do that. And even flood insurance did not cover doing that. So we described 3 alternative make-do options with the considerations, the pros and cons of each of them, so people can then make an informed choice. And that's why I don't label them or call them our recommended practices or recommendations, but reasonable solutions. One of these methods uses closed cell spray foam with a rain screen product against the brick to maintain drainage, because, you know, brick lets water through it like a sponge, and you need to maintain that drainage gap. You shouldn't do the foam right against the brick, even in a warm climate, because then the brick will stay wet all summer long and it'll become a maintenance issue. It'll grow algae. Another method uses closed cell spray foam against that fan fold, that XPS fan fold that they often use behind vinyl siding. It's an inexpensive material you can get, you know, at the big box stores. And that is held in place where the sheathing was, held away from the brick a little bit to allow for drainage. And the third method is a do-it-yourself method, or something that volunteers can do, that uses rigid XPS foam board inserts, because that's a closed cell product as well. I've got a little video. We did kind of a demonstration of these 3 methods, and I've got like a short 2-minute video that I'm going to talk over to kind of show you what those are like. Let's see if I can get it started. Oh, that didn't work. Okay, just a minute. All right, I did the wrong thing. Okay, let's see if that, oh, why is this not done? I did it before.
On your video screen itself, back one screen, sometimes move your cursor to the plate. There you go. Maybe. I don't know.
Well, I tried that.
No.
And because I did it before. Okay. Let me put it here and try this way. No, I didn't do either. I apologize, everyone.
No worries. That's if it's embedded
Here
in the
we go.
PDF.
We got it. I had to do it in the screen. Okay, the first step, or rather, with any of the methods that you use, is this is when the walls are good, it's a great opportunity to chip away at those mortar dropping mountains that are preventing the drainage and clear out the weep holes. So always do that. With the first method, the rain screen and spray foam method, you can get any of these rain screen products and cut them to fit, kind of slide them behind the studs a little bit. You don't have to remove the brick ties. And then get a qualified spray foam applicator who can spray in, just 2 inches, leaving a partial fill, but it'll also seep behind the stud. So it provides your weather resistive barrier and insulation and an airtight system. So it improves the energy efficiency and it adds structural capacity, replacing the structural capacity of the sheathing that's been removed. The second method, you have to remove everything behind the stud so you can slide in the thin fan fold. I have to tell you, this is a pain in the butt kind of method. The workers really like doing it, but it's less expensive because this material is very inexpensive and then you need less foam, but it does provide protection and a weather resistant barrier. The third method is very laborious, takes a lot of time because you have to measure every stud cavity and cut the rigid foam board to fit each one individually. But it's something that homeowners and volunteers can do themselves, and it doesn't require professional spray foam applicators. So it's a do-it-yourself option. The edges sealed with a compatible caulk, then you can add more foam board or other insulation to it. So that's the less expensive if you've got free labor, but it's slow and it's long. So those are options to consider as well. Leaving floods behind now, let's talk about hurricanes. Hurricanes are not just a Gulf Coast thing. They really affect most of our nation, and certainly your 2 states, even Oklahoma. Hurricane wind forces are really like pushing, pulling, and lifting on different parts of the house all at the same time. And also like turning it upside down and shaking it. That's what it's like. So it's not just a matter of holding itself up, it's where could it come apart with all those opposing forces. Then if flying debris breaks a window or pushes in or pulls out a garage door, then the internal pressures of that wind amplifies those external forces, and that's what generally causes actual structural failure. These are the major hurricane damages in order of magnitude of loss claims by property insurance industry. Top of the list you see is roof damages, and then all the water that damage that occurs from that. Then comes window and door failures, and then the water leakage points in terms of the magnitude of loss claims. So this kind of creates a priority of where to invest when you have limited resources. So the roof is most important. In our prototype homes, we had hurricane hardy roofs. We used plywood decking instead of OSB because it is more resilient. OSB is fine, it's strong as long as it doesn't get wet, but plywood is more forgiving. But most important are ring shank nails. They have much greater pull-out resistance than normal nails, and never, ever use staples for roofing in a wind zone. These homes used a total adhesive underlayment, the peel and stick type materials, which is the most robust secondary moisture barrier. As an alternative that's less expensive, go with synthetic roofing underlayment. First, tape the seams with a roof-approved tape and then cover with synthetic properly installed, and that's a great secondary moisture barrier as well. These houses also use the highest wind-rated Class H wind-rated and Class 4 hail-rated shingles to withstand even the strongest hurricanes that might hit New Orleans. But vulnerable points are those vents. Very risky, you know, for damage in high wind are gable vents, turbine vents, and God forbid power vents, which we never recommend anyway. From an air quality and energy standpoint, they create a negative pressure, so they cool your attic by pulling in your air-conditioned air to it. So anyway, but turbine vents tend to come off in a storm. Even standard ridge vents and the soffit vents that just are little vinyl things that sit in a J channel, those are very vulnerable to be sucked out or pushed in and allow wind-driven rain, which then cause ceiling collapse. There are safer options. So for vented attics, Florida has TSA 100 testing protocol. You can find wind-tested ridge vents that can withstand the wind, and they have a wind-driven rain water barrier. Soffits vents should be structural. You can have perforated fiber cement soffits, or use plywood with other soffits like continuous soffits that are actually fastened to the framing, not just resting in a J channel. An alternative to that is the unvented attic system. If there's an unvented attic system, for the energy benefits of putting your air conditioned within conditioned space, it has fringe benefits in hurricane areas. Since there are no vents, there's no chance, no risk of wind-driven rain coming in and the hazards associated with that. Plus, if it's created with a closed cell type spray foam product, that adds deck adhesion and shear load racking resistance capacity. So it actually strengthens the entire roof system. The hip roof, which is used in Green Dream 2, if a hip roof has a moderate slope, that is inherently much more aerodynamic, much more resistant to damage. And it has added benefits. It sheds water away from the walls, the windows, the doors, so everything lasts longer. And it provides shade to all the windows, saving energy as well. So whenever you can get this moderate slope, 6 to 8 over 12 is just perfect for all of these benefits. Of course, homes should have, in high wind zones, should have continuous sheathing to resist racking, but you need framing, blocking behind all the seams so that you can have nails all around all the edges of the framing. Hurricane connectors are the tall sheathing systems to provide a continuous load path. You need to connect all the components together so you have a continuous load path from roof to foundation, so that when the storm comes and it's like turning your house upside down and shaking it, there is no weak link to come apart. This should be specified and detailed and not just rely on the trade to just, oh, I know what to do. But that's an important aspect. Building America has long promoted advanced framing. It saves, lumber, and it allows for more insulation. That's using 2x6 studs spaced 24 inches apart instead of 16. It's stack framed. Everything is aligned, so that makes it strong. So it meets the high wind standards with a couple of little compromises. It allows more insulation with less lumber. And it actually makes the hurricane connections easier because you can go straight from the rafter to the stud and not need in-betweens attaching the rafters to the plates. And it's about the same cost as standard framing generally. Even though using more expensive wood, it's fewer pieces to handle and to install. A couple of adjustments to the standard classic advanced framing that in high wind zones, you really shouldn't go with the single top plate. A double top plate is still needed. And you cannot do just the 2 stud corners because we generally need corner hold downs that require penetration through double studs. So, but you can have 3 stud corners to still get energy corners and get insulation in there. Now you, ever since Hurricane Katrina, you can readily find impact rated windows that with high design pressure ratings for the wind zone or beyond that are also Energy Star labeled, and Energy Star for the exact climate zone of the location. When you're in climate zone 2, look for Energy Star windows for that climate zone because they will be better at keeping out the heat of the sun. Terry?
Thanks, Claudette. So now we're going to talk about tornadoes. Tornado humor there. Next, Claudette. So tornadoes, they primarily occur in the Tornado Alley area, your part of Texas, East Texas, and up through the South Midwest. But I was just in New Jersey, and there was a tornado warning in South Jersey. So they are occurring in other states as well. Next. The really builders will say, can we protect against a category 4 or 5 tornado? That there is probably not much you can do for that level of devastation, but actually all tornadoes that touch ground, really it's category 4 or 5 right where it touches, right at the center. But along the sides, you're getting of even a big tornado, you're getting more into a level 1 or 2 or 3. And certainly a lot of these wind resistance measures we're talking about will protect homes in those areas. And in fact, most tornadoes are not that severe. Next. So there are a couple ways that we can increase the resistance in a retrofit situation or a new home, especially in a new home. One thing to consider would be closed cell spray foam, either on the entire underside of the roof. And you can see the builder in the bottom left actually used closed cell spray foam for his wall insulation as well. But as Claudette mentioned, it adds racking strength as well as the insulation and air sealing benefit. Or selectively, you could just do the spray foam along the eaves, which really helps to tie the roof down to the walls. Next. In a retrofit situation, it can also be helpful to go back and do a 2-part spray foam adhesive along the existing rafters. This could be a time-consuming retrofit, but it's been shown to be extremely effective when they looked at homes. State of Florida University Civil and Coastal Engineering Department did a study showing that when they went and did this retrofit measure, it increased the uplift resistance of these pre-1994, so early code homes by 250 to 300%. And then again, The sealing along the drywall and sealing along the roof eaves can both increase, it's an energy efficiency measure because you're closing off those drafty spots between the conditioned space and the attic, and you're also adding some structural strength. So next slide. Earthquakes are definitely in my part of the country, and actually even in the Southeast, there are places in our country that are at high risk for earthquakes. Next slide. So some of the measures that we've talked about, the stacked framing, the being able to support the load from the roof to the floor and foundation, the hurricane strapping, all of those things will increase earthquake resistance as well. There's some other new construction options you can consider, and one of them is SIPs, the structural insulated panels. Because you've got two sheets of OSB that are continuously adhered with this rigid foam layer in between, it greatly increases the racking resistance of the wall across the entire wall, as well as providing a continuous insulation barrier. Next. There's some famous examples of how earthquake resistant this type of construction is. This happens to be a photo from Kobe, Japan, where within, it was like a 7.2 earthquake that hit Kobe in 1995. Over 5,000 people died and hundreds of thousands of buildings were flattened. But within, very close to the epicenter of the earthquake, there were like 6 buildings standing, and they were all SIPS homes. Next. Another type of construction that we see in DOE's Zero Energy Ready Home program is insulated concrete forms. These are also extremely earthquake resistant because of the rebar that runs vertically and horizontally through the wall every 6 to 12 inches. The insulated concrete forms are the foam block that's held together by plastic spacers. Then they insert the rebar vertically and horizontally, resting on those spacers. Then they fill the wall with concrete, which hardens in place. The rigid foam stays in place to also offer this continuous insulation and air sealing. Next. Wildfires, I think Claudette showed at the beginning that that slide that showed all disasters. Wildfires have definitely been in the news in the last few years with some really extreme wildfire events occurring, especially across the West. Next. Some of the things that can commonly be done to improve wildfire resistance, the Class A rated roofing system, wire mesh over the vents. I'll talk about that more in a minute. Bird stops, gutter leaf guards. Looking at the design of your roof to make sure you don't have a lot of gables and valleys and things that are going to hold debris. Non-combustible finishes and steel doors for your walls. Decks, porches, and fencing that use fire retardant materials rather than wood. And especially the landscape buffer around the home. Next. IBHS did some studies on fire penetration into homes. Their research center is a huge warehouse. They build full-size homes inside this research center and then blast them with wind and rain, and in this case with firestorms. And you could see top left, that's the house being blasted. The house has a typical design with a gable roof with gable end vents, and the photo on the right is sparks literally coming through that gable end vent. You can see them bottom left in daylight, and then also embers coming in through the soffit vents bottom right. So it's been reported by fire departments that this is a typical way that fires get into a house. It's not necessarily burning the walls and burning down the house from the outside, but getting into the home and then catching fire to the insides of the home. Next. So some of the ways that we can prevent that are to install gable end vents and soffit vents. And also, like Claudette said, there's instead of just the little plastic soffit cover vents, actual metal, less than 1/4 inch openings in the vents and screwing them down so that they're not going to lift off in the high wind updrafts that occur when a wildfire sweeps into an area, or doing ventless attic. Next. A ventless attic actually has a lot of energy saving benefits. In addition to keeping out the embers and the windblown rain, it also reduces wind uplift pressures where wind gets into the vent and lifts the roof up from within. It can also keep out pests, birds, etc. The energy benefits, having that conditioned space for your HVAC, reduces the load on the HVAC, the temperature difference that it has to compensate for. It also moves the thermal boundary above all of those ceiling penetrations for electrical, for ducts, for flues, for exhaust fans, etc. It helps reduce the stack effect, and it can simplify insulation of an otherwise complicated, like multi-story home with maybe a lot of soffits or raised ceilings. Next. So all of these things together can help us to build better, both to restore, to increase resistance and increase resilience. The National Institute of Building Science found that for every $1 invested in mitigation activities, you could save $11 in future disaster costs. This number actually changed a couple years ago when they'd done the analysis. It was $6 saved. And now, because of probably better input and increased costs of materials, it's $11 saved per dollar invested. Next.
Okay, let's look now. We're going to show you some examples of hazard resilient high performance home construction projects that have actually occurred. And you've already seen, the green dreams. But one aspect of resilience that we hadn't really discussed is the ability of the home to be functional after a storm or an event has passed. Avoiding damage, of course, is paramount, but even then, people may be without power for days or weeks. So an energy efficient, high performance home can make that much more tolerable and bearable for people, and much easier to condition, with less input if they have a generator or something. So here again, here you can see again the construction features kind of in a summary poster of the Green Dream 1 hurricane, flood, and termite hardy home in New Orleans, with closed cell foam in the walls and then the unvented attic as we've been talking about. And even the more robust flood and hurricane hardy Green Dream 2, which has the rigid foam board to the exterior in the walls and nothing in the wall cavity. Again, termite resistant wood and the unvented attic for the system. This particular house is a simple design. It housed a family of 8. Terry?
Yeah, to add to what Claudette just said about those Green Dream homes and the other homes I'm going to show, the keeping that roof on and intact, because as we know, the Hurricane Katrina, it wasn't just the flooding waters, it was the hurricane force winds. And if you can keep the roof intact using some of these fortified home measures, you're keeping the inside of the home dry. Even if the floor has to be replaced, the ability for the family to move back in quickly after a flood, you just so decrease the time and cost of restoration. Next. Here, I'm going to show a couple examples of homes in Texas and the Southeast. These are homes that were certified to DOE's Zero Energy Ready Home program, voluntary home labeling program. Fantastic energy performance on some of these homes. This particular home by Farrier in Fort Worth had a home energy rating system score of 12 with PV or 50 without PV. So monthly utility bills about $40 a month for the homeowner. And it was a SIP construction, again, that racking resistance against high winds. They triple pane windows, I believe, on this, the heat pump, but all of those, that super high efficiency envelope, if they were to experience a storm, if power were to go out for several days, the comfort level in the home, the ease of being able to maintain a livable environment within the home, even without electricity, is greatly increased by this higher performance envelope. Next. Another Farrier home in Fort Worth. This one used spray foam, used a framed wall, but spray foam ceilings and walls, and a zip panel sheathing, which adds to the weather resistance of the walls, less likelihood of things being pulled off in really high winds. And again, excellent performance on this home. With PV, it was one score, her score of 1, but even without PV, her score of 52, considerable savings over code. Next, please. This is CVF Homes in San Antonio. Again, they used the spray foam in the ceilings and walls and coated OSB, and a SIP roof in this case. Very hardy roof. Next. Custom home in Dallas, 44 without PV. It was a 2x6 construction, 16-inch on center, but otherwise advanced framed, plus they wrapped the house in an inch of rigid foam, plus fiberglass. Next. This was a, this builder does market rate and affordable homes and what he calls working class homes in Southeast Texas. And he uses SIPs for all of his home construction. So you get
Better have a good detail right there above that window where that roof hits. Oh my goodness, that just makes me wince looking at that.
Because, oh yeah, I see what you're saying. Good point. Next. Just another custom home in Houston. Again, they used the spray foam in the attic, triple pane windows. Her score of 39 without PV.
This one is an ICF.
Yeah, it was, which is the insulated concrete form walls down to the foundation. And then next. This was another ICF home in Double Oak. And again, you see that hip roof design, which for most of the roof, which makes it definitely a more wind resistant construction. The hurricane strapping detail is shown there as well. And they used an engineered stud on this, plus open cell, plus rigid wrap of rigid. Next, please. One of the projects I work on for DOE is the Building America Solution Center, which is a great online resource for construction. Lots and lots of photos and videos of good examples of construction and things not to do. So thank you very much for your time.
Oh, and I just want to make a plug to the Building America Solution Center too. You can just Google that term if you don't remember the URL. It is really ingeniously designed, and it's very user-friendly, very builder-focused. It has everything from marketing tools and language and aids, but lots of illustrations, lots of descriptions, and it's keyword searchable. It's just awesome. And
I can't, about 80% of my presentations, I walk folks through the Building America. I wish I knew about it when I was a building official, because it is so fantastic, and it'll give you code references, where to find it, little videos, best practices, and it's grouped, wall, ceiling, HVAC. It is a fantastic reference.
And now they have it in an app form, so you can take it to the field on your, on your e-tablet or your phone and get some illustration guidance to use to help train the trade. So, I'm a big fan of it.
Oh, me too. I show that and construction instruction, and you can take both of those out in the field. And I'm with those two and a little bit of knowledge, you are well on your way. Well, thanks so much. I do have a few questions that came in. With all of the flood remedial restoration methods shown for brick veneer, I did not see here how you deal with brick wall ties. This is a structural component. How do you handle this with no sheathing? And I kind of noticed that when on the one rehab method where he was taking the Sawzall and going in between the stud and the brick veneer, and then they were just sliding that material in between the studs. Well, what kind of brick tie, what kind of retrofit did you go back on the masonry tie?
Well, in the first method, this is why the method I think is the most advantageous and robust is the first method with the rain screen, because you leave the brick ties in place. And so you can just cut the rain screen 16 on center and just put little slits where the brick ties are to just, or just push it around. So they stay in place. So that's great. With the second method, where they have everything behind the stud has to be removed if you want to insert something else like a fan fold back there. You if it's just like the bottom 2 feet from a practical standpoint, residential brick ties probably weren't doing a whole lot anyway. You could do without, but to really be safer and to meet compliance, there are retrofittable brick ties that can be, there's types that you can drill from the outside and they go through, and there are types that can be installed from the inside where you attach to the stud and then go into the brick. So that's an added step and an added expense, which is another reason that second method, I think it's just difficult, and it's more work. So I like the first method. I think the first method, I shouldn't say I like it. It has lots of advantages and fewer disadvantages except for cost. It's the more expensive with the rain screen and the closed cell foam. With the rigid foam board, the do-it-yourself option where you don't need a spray foam applicator, again, the brick ties are still there. They stay in place. The problem is that you don't have the foam providing the WRB behind the studs. You have nothing to protect the exterior side of the stud. So what I would say is, when cutting away the old damaged sheathing, cut it along the studs and leave the sheathing behind the studs to be better than nothing. The other option is that if the sheathing is completely removed and the studs are barren and you're using the rigid foam board inserts, you could do kind of a spray paint application to the back of the studs to at least reduce their absorption. Again, it's not a perfect solution, but But if you can't remove the brick veneer and you got to remove the sheathing, it's an option.
Yeah. Got to do something. Yeah, I love when you showed and then you actually mentioned, it doesn't have to be an all or nothing approach. And I joke that if I ever fall off the wagon and become a building official again, a few simple items like, I've taken that fortified evaluator class and something as simple, and it doesn't even have to be the whole roof, but if you just do the one sheet around the perimeter of a roof with a ring shank nail, you're going to add less than $50 cost to that house. And that's where you lose your roof deck, at the edge. And something as simple and now, as a building official, I understand the pressure when you're sitting in front of city council or your building standards board. You can't hit the builders with, hey, we're going to have all of our homes fortified with the certification, because you're talking about adding $1,000 plus delays in the construction process. But if you're doing something as simple, hey, builders, we're going to do ring shank nails around the perimeter of all of our roofs, I think you can get your builder buy-in on some of these simple things that make a real big difference. And so
it's a matter of, what gives you the most benefit for the cost. So it's forming a priority. And that's why I say, best practice is one thing, but then there's reality. What can people afford? What
Right.
can people get and do? And so, I'm not about, my program is not about, here's the letter of the law and regulation, which I know you guys have to deal with. It's about, it's about helping people, doing something that's beneficial is a whole lot better than doing nothing. And so there's a whole lot of doing nothing out there, just putting it back exactly the way it was, which is sad, because then this is going to happen again. If you flood once, if you get hit by a hurricane once, it will eventually happen again.
Absolutely. And Terry, I didn't know that was actually tornado humor. I thought PNNL did an actual statistical analysis, and tornadoes do actually prefer manufactured housing. Did I not read that somewhere?
Dang, you're right. Yeah.
And then okay, one more question came in. It says, any idea of the insurance benefit of being 2, 3, or 4 feet above the base flood? I know you're not in insurance, but you got a guesstimate on
yeah, there's a big drop in the rate. I mean, it depends, the insurance, servicer would, it's specific to the home and to it, but in general, your rate drops a little bit when you're a foot above BFE, and then it drops a bunch more when you're 2 feet above BFE, and then just a little bit more drop at 3, and then past that you don't really get any drop in your premium. So the sweetest spot is 2 feet above, but you might as well go 3. It's a better cushion. It's it's not going to cost much more than going up 2 feet, depending upon your situation. Now, if your BFE is right at grade, you can go 2 feet up with conventional kinds of mound and slab over that, and that sort of thing, and then dig out your grade beam. But so it can get a little bit more expensive to go beyond. So it just kind of depends upon the site and where the BFE is in relation to the grade as to the impact it would have on the foundation. But just think about, not having to go through, the aftermath of a flood and how disruptive that is. And it's not just disruptive to the family, it's disruptive to the entire community. I mean, Texas, you folks in Texas, you just went through it not long ago. It really takes a huge toll. And so, because it affects so many people at once. So as much as we can encourage, I'm not, an advocate of necessarily requiring it, but, local ordinances that would require freeboard, of a foot above can also bring lower insurance rates for the entire community. So certainly encourage that. And I guess I clue you in. I don't know when or if this will actually occur, because I know pandemic has taken a toll on everything. But there is a movement to adjust the flood insurance program to where ICC, that extra rider, can only be used like if people are substantially damaged, and then they're required to elevate to BFE and to bring everything up to code. That is rarely used because $30,000 that it provides is not enough to elevate a typical home, especially if it's slab on grade. And so, it has not been effective in improving the housing stock's flood resistance and resilience. So there's a movement to try and have it incorporate, and for claims to be able to pay the extra cost of wet flood proofing. In other words, flood hardy restoration using flood damage resistant materials and assemblies. And I hope it gets enacted, because they did an economic analysis that shows, it'll cost more, from coming out of the FEMA coffers, the flood insurance program coffers initially, but after the next flood, they'd be way ahead in the reduced restoration costs the second time around. So, there's so many repeat flood claims that I really hope they can get that passed, because otherwise it's just up to the homeowner to fund the added cost of putting it back better to be more resilient and energy efficient.
Right, that makes sense. Well, and I like that y'all mentioned that this is kind of a segue into the National SIPS Association will be doing a webinar for us either at the end of this month or first of next month. So that will be our very first SIPS webinar. So I'm looking forward to, I'm glad y'all mentioned a little bit about that. We'll be doing more about that. And I love that you mentioned, and I couldn't agree more with you, Claudette, the power events, a bad idea for the most part. And then also wanted to comment on your graciousness and humility, Claudette, because I don't know how you couldn't have opened with national championship tigers. I mean, some sort of nothing.
Well, I could take personal credit for it, but, to tell you the truth, I had absolutely nothing to do with it, and I did, it wouldn't have happened. So I can take credit for that.
I thought you were personally responsible for recruiting Joe Burrow, Okay. Well, ladies, thank you so very much for your time. That's all the questions. Really a fantastic job. For everyone on the webinar this morning, you will get a follow-up course evaluation for ICC CEUs. Simply fill out the course evaluation and we'll get you your ICC CEUs. Be on the lookout for the invite for the SIPS webinar at the end of the month. Next month, we have the Buried Ducks in the 2018 IECC running next month. Again, thanks so much, ladies. Fantastic job. Those weren't lies that I was hearing about this presentation. I really appreciated it. That drainable, dryable wall assembly reminds me a lot of how I'm constructing the walls in my cantina bar that I'm building in my backyard right now.
Ooh.
Fun stuff. Well, when you're stuck at home, you need a decent backyard. So I've been working on my backyard like crazy for the last few months.
Great. Sounds great. Well, thank you for the opportunity to share this. And I'd encourage people to visit the Building America Solution Center and also the House Resource Center website. That's where you can find the FAQs along with a lot of other, online publications and resources that we have as well.
Great. And everyone will get a PDF of the presentation. So if you forgot anything, it will be on the PDF. Good to go. Thanks again, ladies. Thanks, everyone, for joining us this morning. And we will see you next week.
Thank you.
Bye.